So we're on page 8. We're coming to a new definition, and this is power. Power is the rate of doing work. If I wanted to hire you for a job, I wouldn't want to know how much work you can do, but rather the amount of power you have. Your power tells me how fast you can work. So the definition is power equals work divided by time. In terms of a formula, power is capital P equals work is capital W divided by time, which is lowercase t. The MKS unit for power is a watt. And if you look at this formula, it gives you its own units, which we call watts. It's actually joules per second, which is what makes a watt. So example 1, Joe lifts a 50-kilogram box to a 2-meter high shelf in 3 seconds. Find Joe's power. So power equals work divided by time. So we have to figure out what is the work here. Remember, work is a force divided by a distance. Force times distance. Force exerted over a distance. Work was also equal to the change in kinetic energy. And yeah, we're lifting it, so that's fine. But when we were talking about lifting, we were really talking about a change in potential energy. This one was our lifting, this one was our pushing, this one was a generic formula. Work equals the change in potential energy, which is mass times gravity times the height. And so we'll come back to our formula here. Change in potential energy over time, or mass times the acceleration of gravity times height divided by time. So putting in some numbers, we know the mass was 50. We know the acceleration of gravity is approximately 10 meters per second squared. And the shelf has a height of 2 meters. Really, h, we could also say that is delta h, or the change in height. All of this divided by time, which is 3 seconds. We've got 50, 500, 1,000 divided by 3, 333.3, repeating. Cross that off. And our units, kilograms times meters per second, that's a Newton. This is a Newton meter, which is a joule. This is a joule per second, which is a watt. 333.3 watts. Number 2, a 1,200 kilogram car can accelerate from 10 meters per second to 20 meters per second in 4 seconds. Find its power. So here's power. It's work divided by time. A few ways that we could figure out force, but the we're going to use change in kinetic energy for this one, because basically horizontally, that's a push, that's changing the kinetic energy, not the potential. We could figure out the force. It would take longer. It's just faster to use kinetic energy. Change in kinetic energy over time. And so here is our formula for kinetic energy: 1/2 mass times the velocity squared. Power is divided by time. But we have a changing velocity, so we're going to do final velocity. So 1/2 times the mass times the final velocity. And you have to square the whole quantity minus the initial kinetic energy. Mass is the same, but the velocity is 10 meters per second. And we're squaring that velocity too. So really this is Vf squared and this is Vi squared. And all of this in a time of 4 seconds. So what you come up with is 180,000, divided by 4. 180,000 joules in 4 seconds, which comes out to be 45,000 watts, or just abbreviated with a capital W, it's fine. Or in other units, because 45,000 is a pretty big number, 45 kilowatts. This is a more familiar unit for power. It's one that you might see in terms of electricity, kilowatts. Example 3, a horse can pull a plow a distance of 200 feet using a force of 275 pounds in 100 seconds. Calculate the horse's power. So power is work divided by time. With this one, we've got a force and a distance. So we'll use force times distance, and dividing it by time makes power. $275 pounds. Distance is 200 feet. Time is 100 seconds. So we got 550 units, foot-pounds per second. $550 foot-pounds per second, or in other units, 1 horsepower.